Interestingly, it's composed of, we think, 3 separate volcanoes, or at least it's erupted in 3 different ways. If you fly over the top, you see 3 separate calderas. So it isn't just 3 times larger. This is a monster geological event. But in fact, if you were on the edge, the slope is so gradual and the peak is more than 100 miles away that you wouldn't know that it was a volcano. It's that massive.
And Olympus Mons is not alone. A few hundred miles southeast of the mountain stands a diagonal row of 3 other evenly spaced enormous volcanoes, each larger than any of its type on Earth. Yet, as magnificent as it is, the Tharsis region isn't the only spectacular geological feature discovered by Mariner 9. At the eastern edge of the bulge is a colossal tear in the crust of the red planet. It's called Valles Marineris, Mariner Valley, in honor of the Mariner 9 orbiter itself.
You look at this thing, it is like the width of the United States. It's this cleaved valley. You know the Grand Canyon in the United States? Pump it up, put it on steroids, make it the size of the United States itself, you've got Mariner Valley.
The geological mechanism that caused this immense rupture in the Martian surface is yet a mystery. Scientists can only speculate.
One mechanism which I like is that there's a place called the Tharsis Bulge not far away, in which so much lava and other things have accumulated that it's felt it could put a giant torque on the surface of Mars and pull this apart like a zipper. Well, who knows if that's true, but one needs a mechanism different from anything that we know to explain the existence of that.
With the stunning success of Mariner 9, the next logical step for NASA was to land a spacecraft on the actual surface of Mars. Scientists were eager to test rock and soil samples for signs of life. In 1976, the Viking mission reached the planet to do just that. It had both an orbiter and a landing component, equipped with robotic test instruments.
And we get right down on the surface and we scoop up some soil and we don't find a thing. Mars looks like a cold, dry, dead place.
But while the Viking lander toiled away on the ground, failing to make headlines, high above the Martian surface, the Viking orbiter managed to capture a mystifying image. While flying over a region of Mars called Cydonia, the orbiter snapped an image of a land formation under cross-lighting. Startlingly, the formation resembled a human face. As a joke, NASA scientists showed the photo to the press, remarking about the face they'd found on Mars. Under more even lighting conditions, of course, the Martian terrain feature does not look like a face at all, just a jumble of hills. But in certain circles, the story of the face on Mars and its NASA cover-up persisted for several years. True Mars enthusiasts, on the other hand, faced a more sober reality following the Viking mission. With no definitive evidence of biology resulting from the Viking experiments, interest in returning to the red planet quieted for several years. Then, in 1984, a young scientist on an expedition in Antarctica made a discovery that ultimately infused new energy and hope into the quest to uncover life on Mars. In December 1984, NASA geologists on a meteorite gathering expedition in Antarctica found an odd specimen. A meteorite with an unusual color, a sort of green hue. Most are gray or brown. Back at NASA's Johnson Space Center in Houston, where such rocks are stored, it was labeled ALH 84001. Despite its odd color, the scientists assumed that it was a piece of an asteroid.
So the rock was pigeonholed into a group of meteorites, and it stayed there for 6 or 8 years. Misclassified.
Then, in the early 1990s, an analyst researching asteroids placed a piece of ALH 84001 under an electron microscope. He soon realized he was not looking at a normal meteorite. He was looking at a piece of Mars. The rock had characteristics that matched another Martian meteorite found in 1979. More scientists began studying this sample, and they were astonished when they eventually found what looked like carbon globules. Carbon, at least on Earth, is the primary building block of life. Senior scientist David McKay headed up the research group.
My imagination was ignited by the carbonates. And I said, hey, these carbonates are really strange looking. How do they form? Let's look at those.
Closer scrutiny of the rock sample brought even more startling discoveries.
The kind of chemistry that went on in those globules is associated with life.